Hello, my dear students. Assalamu alaikum. Today we're going to learn how we can draw a two ring, okay, and how we can assemble this two ring in this way. That means inside each other. All right. And the second thing we're going to learn, if we apply the external load in any of the side, keeping one side in static positions, what kind of contact pressures will be generated in the contact places, okay, in this two ring. That means here what will be the conditions of the contact pressures in this area. All right, so this will be our learning objectives of today's tutorial. So at first we'll learn how to draw this. We'll draw the part drawing first, then we'll assemble this ring, and then we'll run a simulations to demonstrate to you how we can measure the contact pressures in this area when external loading will be applied in any of the side of this two ring. All right, so without further delay, let's get started. So we'll start with the part drawing first. Okay, so our first task is to draw a ring. So we can start from any of the plane. Okay, so let's start with the front plane. Again, I'm saying there is a couple of way to draw a ring actually. So now I'm just showing you one. Okay, so I'm drawing a reference line first, then I'm drawing a circle. Okay, then I'm giving it a smart dimensions with, let's give this one as 20, and let's give distance from center line to here as 50. Okay, now what we need to do, let's go to the features and revolve boss base. Okay, if we just select this face, automatically it will take the axis of revolutions here. This is our axis of revolutions and this is our thing. So actually here the 360 degree is given, so we can also change the degree as 200 degree. Okay, or we can also increase this one, but to make a ring actually we need to it should be must 360 degrees. So without further delay, let's put 360 degree. All right, so now we have a ring, but the problem in this ring, there is no flat surface where we can apply the load, and we cannot also put any boundary conditions, because if we select on this ring, the whole ring will be selected. So that's our problem. So we need to create a flat surface in this ring. So let's do it. So let's select this right plane. So there is a couple of way to do it, but let me show you the most easiest way. Actually, if you see the right plane, so if you select the right plane or top plane or front plane, any of the plane, what you are, it is exactly in the middle. That means if you draw anything, all the drawing will be in the middle plane. All right, so that will not help us. It will not, whatever the drawing will be drawing here, to not help us to remove or add some material on the ring, right? So what we need to do, we need a reference plane. So let's select the right plane and let's select the reference plane. So if we select a reference plane, so you can select any of the side, either this side or that side, and you need to put a distance from here, right? So from here the distance will be, it's now here the distance is selected 50. Okay, you can reduce this one 40, 30. 30 is not going to help us. 40, yes, somehow it will help us, but 50 exactly in the middle of the ring, right? Almost, right? As we have selected from the center to the radius was 50, so let's keep this distance as 50. Okay, so done. Now we have a plane here. Now we have a reference plane. So now if we select this plane, now if we draw anything here, it will be on inside this, like here. It will be drawn here, right? So the thing that we want to do, right? So here, let's select this plane. Now let's draw a center rectangle, all right? So let's draw this. Now let's give a dimensions. Yeah, okay. So let's give this dimension as 20. And this distance is 95 is too much. I think 70 is good enough for us. Okay, yes, let's give this one as 70. All right, so 70. Now if we use extrude boss base features, okay, as you can see from 50, if we select like this, 10 if we give, it's good enough for us. Okay, if we give 10, what you can see, we have a flat face here over here, and it will help us in many ways in the assembly as well. Okay, we can select the face to mate with each other. All right, so now one portion is done, but to fix the ring inside each other we need one more thing actually, right? Because we can select the make the axis parallel with each other with this surface, but how we can mate these portions, because if there is nothing, if we select this whole ring will be selected, right? So we need to create some point here so that we can select it in the assembly. All right, so for this what we can do, let's again we can select. So now let me just show you. Okay, so let's select the right plane once again. Okay, here now let's draw a very small circle. Okay, very small, very small. The radius I'm gonna give is 0.5, that is the diameter is 1, right? So now what I'm doing this, I will use now extrude cut. And if you remember the distance from here to the this surface, that means the inside of the ring, it was total was this 50 minus 10, that will give us 40, right? So if we select 40, okay, and if you make extrude cut, it will just touch the surface, and we are going to get a point. Okay, we are going to get a point here. This point it will help us in the assembly sections. All right, so can you see this point? I think yes you can. All right, just let me check it's running. Yes, the video is running. All right, so yes, our part drawing is done. So now let's save it. Okay, so two ring simulations. Okay, so ring 1, let's give this name. Okay, so now our part drawing is done. Now let's go to the assembly sections. So let's select assembly. Okay, now so we have just drawn this. All right, so ring 1, we need actually another ring, right? So let's select another ring. Okay, okay, so now actually we want, what do we want here? We want to insert this ring with each other, right, inside each other. So this is actually, you can move this one. Okay, to make float you can move both of them by floating, use floating options. Okay, or you can fix also this one. So let's make this is fixed, now this is float. Okay, also you can, which one is floating and which one is fixed, you can identify by here. This F, right, F means fixed, and this minus means you can move this one around. All right, so what we'll be doing first, let me show you. We'll mate the faces, right? So let's select this face and let's select this face. Okay, let's select parallel. Okay, but as we can see, we will this face, as you can see, we will select in this way. All right, this way parallel, but in the opposite way. So if you select it, okay, now we can move this one in this way. All right, okay, you see, we can move this one in this way. Okay, so also we can select this face and this face as parallel. Okay, now what we'll be doing, there is other way to do it as well. How? Let me now, what we can do, we can select this front plane for ring fixed one, and also we can select this front plane and we can select perpendicular to each other, which will also serve our purpose. Yes, now it's fully defined. Okay, now what we'll be doing, we'll select this point here, and we'll also select this point here. Okay, now coincident. Yes, if you did do this, now our task is done. Yes, now it's now fully defined. As you can see, now we have two ring assembly which is inside each others, and we are ready for our next step, that is the simulations. Okay, all right, fine. So this is, I don't think it's very difficult, it's easy, right? It's easy to perform. So if you are done, if you understand from here, now we are ready to move to the next section. Okay, so now If you don't have simulations in this ribbon, what you can do, you can click on the SolidWorks add-in. Then here you will find SolidWorks simulation. Then if you click here, then simulation will come here. Okay, so after simulations, select new study, and it's a ring assembly. Let's give this name contact pressures of two ring. Let's give a name. Okay. So if you do this, the first task is to define the material property, what material you are going to use. Okay, so to select the material, you can give different kind of material for different parts, but as we are using the same kind of material in two ring, so what we can do, we can select right click here, then click on the apply material to all. Then we can select AISI steel, AISI 1010 steel, hot roll steel. We can select this one. If we now apply, what you see, you will be seeing that yes, AISI 1010 steel hot roll bar is selected for both the cases. Okay, and the color is also changed accordingly. All right, so this is our first task. All right, so now second task is if you select after doing this, you see connections. In the connection, if you click here, you will see that global contact bonded. It's bonded here by default, but you need to click here. If you click here, it's not bonded actually. You need to select the contact type, no penetrations. All right, so why no penetrations? Yes, our expectation is when the load will be applied here, this ring, as it's steel made, definitely it's not going to penetrate inside each other. That means, right, and it's not bonded as well, and we don't want to allow penetrations here as well. Okay, where you can use bonded, yes, if you like in composite material, one layer is attached with another layer with some kind of chemical adhesions. At that time you need to use bonded. And when you can allow penetrations, if you are working with rubber type materials where some sort of penetrations or shock absorption is allowed, at that time you can allow penetrations. All right, so we have selected no penetration for our simulations. Now we have to select fixtures. In the fixtures, you need to select the fixed geometry. Let's select the fixed geometry. Fixed geometry is when you will be applying the force, definitely other end definitely need to be fixed. So that's why fixed geometry is important. So for fixed geometry, let's select this face as our fixed geometry. If you select some face, this kind of three direction arrowhead will be applied. What does it mean? That means this green arrowhead, it's showing XYZ direction. If it is green, that means there will be no displacement in these three directions, and it is completely fixed. Okay, remember this one. This is our fixed geometry. All right, so you can select this this face as our fixed geometry. Okay, so I think you can select all the faces actually, but it will not create any difference for this kind of, because if this face is fixed, other face is automatically is fixed as well. So let's do this. So we have selected this face as our fixed geometry, and we'll be applying load here. Okay, in this face. Okay, so now there are a couple of things, more boundary conditions we need to give. So for that we need to select right click on the fixtures, then advanced fixtures. Okay, in the advanced fixtures, actually we need to select where we'll be applying the load here, this face, and which directions it will actually translate. That means it will move, right? So it is in these directions, front, in this way. So when we'll be applying the force, it will move in this way, right? So front. So now we need to restrict the movement in other two directions. How we can do this? So if we select here, you will see there is a arrowhead. We want the displacement in this direction 0. All right, so in this direction we don't want any movement in the, you see the arrowhead directions in this direction. We don't want any kind of movement here in these directions. All right, so now again let's select here. Yes, it is again in these directions. Okay, so this is X, this is Y, this is Z. So that is why in Y and Z directions, as you can see here, Y and Z directions, I have restricted the movement. The value is 0. So I just want the value of displacement in X directions. So X direction, keep it in this way. All right. So we are done up to here. Okay, now let's give a external load in terms of pressure. So we'll be applying pressure loading, Newton per millimeter square megapascal. Let's select this one, Newton per millimeter square megapascals. So let's give a load of 5 megapascal as well, maybe. Yes, let's give 5 megapixel. Okay, but where we need to, yes, sorry, there is a mistake. Where we need to give the 5 megapascal? Yes, here in this phase, right? But you can see the arrowhead in this way. If we give a load in this way, it's not gonna help us, right? So you can select reverse direction so that the force is applied in the right directions. So done. Okay, so we are done with the necessary conditions. All right, so our next step is to create the mesh. Actually, this is the very important steps of simulations, creating mesh. Okay, so now I will be showing some of the tips and tricks to do fine mesh. Okay, uh, the more smooth your mesh is, the more time it's gonna take. If your mesh is coarse, that means a bigger size, then it's gonna take less amount of time to end the simulations. Okay, so let's select apply mesh control. Okay, now let's select this face and this face. Okay, I want here in this area, I want very fine mesh. Okay, so that's why let's if I want fine mesh like this, let's this, you can also put your own value as well. If I put 1.5, yes, I can put the minimum mesh parameter 1.5 millimeters. All right, and I can select here in this way. Now I need to go to the create mesh portions. All right, now there is standard mesh, there is curvature based mesh. Actually this is a curvature based mesh. We need to select curvature based mesh. Okay, if we select curvature based mesh, okay, and if I select coarse, what will happen, let me show you. And then if I select like this, what will happen, let me just show you. Yes, it's done. As you can see, as we have selected curvature based mesh in these two ring, that's why you can see that in this curvature the coarse mesh is very fine, but in this area the mesh size is coarse, that means a bigger size. Okay, so because our interest is in this area, that's why in this area also you can draw it in such a way that we can make a partitions in this here, and we can select this face and this face, and we can put this two area as a very fine mesh and other area as coarse mesh, which will help us effectively reduce the computational time. All right, so uh, we are almost done with uh, the necessary arrangement for the simulations. Now what we need to do, okay, we need to run the study. Okay, let's click run this study. It's gonna take some time. Okay, depending, as you know, we have given a very fine mesh, so it's going to take some time. So let the simulation complete. Actually, we need to keep wait. I think we need to wait for a lot of time. So let me cancel this solver. Okay, because it's going to take some time. So let me just show you some other way to, okay, create mesh. Okay, here we can select fine mesh, not fine, coarse mesh. Okay, okay, let me select this one, and let me show you mesh progress. I think I need to go to the mesh, apply mesh control here, and I need to select this face and this face, and I need to select coarse so that to reduce the computational power, and also I will select create mesh here, and let's select coarse here. I think something is wrong with the control. Let me delete this. Actually, it's already saved. Let me delete this one as well. Okay, let's do it once again. Let me show you. So here, apply mesh control. Let's select this face and this face. Let's select as coarse a little bit. Okay, and then let's go to again apply mesh control. Okay, sorry, not here. Create mesh. Okay, curvature based mesh is selected already. Now select this. Now it will be very quick. Yes, as you can see. Okay, so the reason I did this, because it's going to take a very less simulation time, computational time. You know, it's, you see it's solving very quickly. uh, if you need a very perfect results, definitely you need to use a fine mesh. Okay, as this is the tutorial, the I've selected this one. Okay, let's wait for a couple of time. Yes, the simulation is done. Now we are ready with our results. We can see the stress is developed in this area. That's why the color is changed here. That means the green, the blue color means there is no pressure at all in these areas. Okay, and the color that is here, uh, showing here, that is the green color. That means it is within the range. If the color is, if like this, if you see color, observe a color in this kind of, that means it's in the danger zone, and we need to modify your designs to be the pressures within the green or blue range. All right, so now this is our von Mises stress, and if you click here, then you will be able to see the displacement here. Okay, the displacements in millimeter, that it is, I think, 1.1 10 to the power minus 0.1. That means that the maximum displacement here is 0.1 millimeter after applying this load, which is very less. Okay, and also the maximum stress here is Newton per millimeter square. That means 1.8 into 10 to the power 8 megapascals, which is here. Okay, all right. So now it's possible to see define the stress plot. If you select here define stress plot, then we can select here the contact pressures. All right, now if we select the contact pressures, then you will be able to see the contact pressures that is acting here in this place. All right, so we can neglect, there is some additional here we can remove those by okay. So if you select here external loads, hide all, this arrowhead, others arrowhead will be, then if you select here, if you select hide all, then others arrowhead will be removed here. So now here we can see the contact pressure that is acting in this place. All right, so also you can change the size of the arrowhead by clicking here, and the vector plot, then if you select this arrowhead, you can change the size. So this is how we measure the contact pressure in this two-ring assembly. Okay, if you change the external loading, and these values, all the values will be changed accordingly. Okay, so this is all about today's tutorial. I think you have understand because this whole tutorial. If you have any questions regarding today's tutorial, please send me an email. Okay, thank you very much, and next week I will be uploading another tutorial. So till then, goodbye. Thank you very much.